Hello class, Dr. Barnes here. So let's take a look at these signals. We're going to analyze them with Fourier transforms. Sorry, Laplace transforms. Okay. So these are very simple ones. Let's just go straight into it. So A, x of what? T is equals to e minus what? 5t into u of what? T minus 1. First, let's represent this unit step signal. So to represent this unit step signal, we shall have like this. Here is what? T. Okay, here is what? X of what? T. Okay, and here is what? 1. Okay, here is what? U of what? T minus 1. But u of t minus 1 actually cannot be, it has to be here. And here has to be what? 1. Here has to be 0. Okay, so please let me draw the unit step signal again. Okay, so the unit step signal will become here t. Okay, here like this, x of what? T. Here is what? 1. Okay, because t is equals to what? 1. T minus 1 means that t is equals to 1. So like this. Okay, and then here is what? 1. Okay, here is what? U of what? T minus what? 1. So this becomes our what? Unit step signal. This becomes the unit step signal. Okay, so now knowing this unit step signal, let's go straight ahead and then realize the Laplace transform for it. So Laplace what? Transform for what? X of what? T is equals to what? Minus infinity to what? Infinity. To infinity. X of what? T into e minus what? St d what? dt. Okay, so we have which is equals to e minus what? 5t into u of what? T minus 1. U of what? T, okay, minus 1. T minus 1. Okay, into e minus what? St d what? dt. Okay, so now what we can have from here is that we can have here, you see that the signal is starting from what? 1 to what? Infinity. This place is what? Infinity. 1 to infinity. So here I can put 1. Okay, and then, or better still, let me just maintain minus what? Infinity. And then let me maintain what? Infinity. And here, let me maintain what? 1 to what? Infinity. And here, I know that this guy is what? 1. So if it's 1, then I can 1 multiplied by this one will be the same as this one. So I can write what? E minus what? 5t into what? E minus what? St into the what? dt. Okay. So now if I have this one, then here E, here infinity. Okay. So I can have E, okay, minus S, okay, plus what? 5 into t. Okay, dt, and this is equals to what? This is actually equals to the integration. Okay, it's equals to the integration that I'm going to have here. Okay, so basically I have 1 over minus 1 over s plus 5. Okay, over s plus what? 5 into minus s plus what? 5 into t. Okay, here is what? 1 and then what? Infinity. Okay, so now here, if I should put in my limit, I'll have minus 1 over what? S plus what? 5 into what? If I put in infinity here, okay, you see that this place is what? This is negative. This place is positive. Why is it positive? Because the signal is going this way. It's at the positive side of the x-axis, so it's positive. And here is infinity. So I'll have what? Minus what? Infinity. Because here is minus, here is positive, here is what? Infinity. So I'll have minus infinity. And then here, I'll put 1 here. If I put 1 here, I'm basically going to have e exponent what? Minus s plus what? 5 into what? 1. Okay, so that's what I'm going to have here. Okay, so now, if I have this one, then what I'm going to actually have will be like this. So here, e exponent minus infinity is 0. So I'm going to have 1 over what? S plus what? 5 into here negative negative positive, okay, into what, e minus what, s plus what, 5, okay. So that is what I'm going to have, okay. So now the Laplace transform. So now my Laplace transform, what I can say is that if I have e exponent minus 5 what, t, okay, into u of t minus 1, then my Laplace transform is going to be what, e minus, okay, here s plus what, 5, okay, over what, s plus what, 5, okay, s plus 5, s plus 5. Okay, so basically that is what I'm going to have. Then what is going to be my region of convergence? Okay, my region of convergence is going to be such that I'm going to have s plus what, 5, or I'm going to have 5 plus 5 plus what, 5, which is what, greater than 0, because my region, the region of my unit step signal is lying at a region which is what, greater than what, 0, because it's lying at the positive side of what, of the x-axis, okay, at the positive side of the x-axis, okay. So for my ROC, okay, I'm going to have this one. I'm going to have 5 plus what, 5 greater than what, 0, and then 5 is what, greater than minus what, 5. So real of what, s is greater than minus what, 5. So here I can say that real of what, s is greater than what, minus what, 5, is greater than minus what, 5. Okay, so that will be the solution to this particular example. Okay, to this particular example. Okay, so quickly let's go to the next one. Okay, let's go to the next one. All right. So in the next one that we have, we're going to have B. Okay, we're going to have B. So what is B? B is such that x of what, t, is equals to e exponent t into sine what, 2t. But we have to always also remember that we are given that t is greater than or equals to what, 0. So that means that the signal is lying at the positive side of the what, x-axis, okay, at the positive side of the x-axis. This will be very important when we are analyzing our region of what, convergence. Okay, so now here Laplace transform of x of what, t, in this case is going to be here minus infinity to what, infinity, okay, x of what, t into what, and t into e minus what, st the what, the t, and this should be equals to, here we know that our signal here, t is greater than or equals to what, 0. That means that t is starting from what, 0 to what, infinity, okay, and our signal is what, et into sine what, into sine 2t, okay, into what, e minus what, st, okay, the what, dt. Okay, so that is what we're going to have. All right, that's what we're going to have. So now this one, what we can do is that we can have here, we can have the signal to be this particular way. Okay. Hello. Please, let's analyze something here. T is greater than or equals to what? Sorry. T is less than or equals to 0. T is less than or equals to 0. It's not greater than. It's less than. Okay. So that means that t is occurring at the what? At the negative side of the x-axis. Okay. Because t is less than or equals to what? 0. If it's less than, that means that it's at the negative side of the what? X-axis. So that minus infinity to what? To 0. Alright, sorry. So minus infinity to 0. Okay, so now if we have that, then we can see that minus infinity to what? 0. Then here I can just have these two. Okay, these two I can have what? E into what? Minus out. I can have s minus what? 1 into what? T. Then I can have sine what? 2t. Okay, d what? dt. Okay, I can have this one at this particular stage. Okay, so if I should expand this one, then I'm going to actually get if I should expand it, and then I'm going to actually get here 0. Okay, sorry, here minus infinity, and here 0. Okay, then I'm going to have e minus s minus t. Sorry. Minus s minus what? 1 into what? T. Okay, into t. Then this one, please, if you remember from our previous lecture, we expanded this one and we got what? Into exponents, into exponential functions. Okay, so if you expand this one, please visit that one to know what we did over there. Okay, one of our previous lectures. Okay, so here we have e into what? J2t. Okay, minus, okay, e into minus j2 what? T. Okay, into minus j2t. Okay, here then you close it like this, over what? Over 2j dt. Okay, so this is what we're going to have. Okay, so now we can just move on from here. Okay, so now moving on from here, this is what we're going to actually do. Okay, so now here we're going to have this one into this and this one into this. Okay, so I can bring 2j out. Okay, so I can bring 2j out of the integral. Okay, 2j can come out of the integral. So now I can say that 1 over 2j, which can come out, is going to be here. I can have e exponent. Okay, please, my integral here is minus what? Infinity, and here is 0. Okay, so here is going to be what? E exponent minus what? S. Okay, so s minus what? 1. Okay, and then this one, s minus 1. Okay, minus 2j. Okay, minus 2j. Okay, into what? Into t. Okay, into t. So that if you multiply minus times minus here, you get this positive. Okay, you get this positive. And then what I also have again is that, so here I can bring what? The t. Okay, then the next one I can bring this minus. This minus can also come. And then I can have here minus infinity and then 0. So here I can have e minus, okay. Here I can have s minus what? 1. Sorry. S minus 1, okay, plus, okay, plus what? 2j. Then I can close it into what? Dt. Okay, then here now, what I can do is now I can close it like this. Okay. So now I can just close it like that. So now here, from here going, what I can do again is to just integrate. Okay, so if I integrate, then I'm going to have 1 over 2j, this 1 over 2j. Then let me bring this one. So I'll have minus 1 over s minus what? 1 minus what? 2j. Okay, s minus 1 minus 2j. Okay, into here. Okay, e exponent what? E exponent minus s minus 1 minus 2j. Okay, all right. So what are the limits here? The limits here are minus infinity to what? Infinity. So minus infinity to what? Infinity. Okay, then I come here. If I integrate here, I'll get what? This is minus. If I integrate here, I'll get minus 1 over. So minus minus will be positive. So I'll get plus 1 over what? S minus 1 plus what? 2j. Okay, and then I'm going to have e into what? E into minus s minus 1 plus what? 2j. Okay, here limits as minus infinity, and then what? 0. Okay, then I can close here like this. Okay, so basically that's what you can get over there. Okay, now from there, what we can do again is to just introduce our limits. Okay, so if we should introduce our limits into these equations, then I'm going to actually have here, if I should introduce 0 here, I'll get 1. If I should introduce minus infinity here, if I should introduce minus infinity here, I'll get what? 0, because any number exponent minus infinity is what? Is 0, okay? Is 0. And then here, what happens is that I'm going to have 1 over what? 2j into what? Here is minus 1 over what? S minus 1 minus what? 2j. And then here, I'm going to have e exponent what? 0. And I'm going to have minus what? E exponent what? Minus. This minus is this minus. And this place is also negative. Why is this place also negative? Because I'm told that my t is lying what? Below 0. Okay, at the negative side of the x-axis, because t is less than what? 0. So if t is less than 0, that means that it's at the negative side. So this place is also what? Negative. So have this negative is here, and this place is also negative. Okay, and then this one. Okay, this one. So please, here has to be what? T, because you see that there is t here, there is t also here. Okay, so this place has to be t. So this t here, I'll put negative infinity there. So negative what? Infinity. Okay, plus 1 over what? S minus what? 1 plus what? 2j into what? E exponent what? 0 is 0. And then here also minus e exponent what? Here is also the same thing. Okay, minus, okay, minus what? Infinity. Okay, so basically here it's going to be like that. Okay, then you have this one. Okay, so now here, if you have this, what you're going to get is that you're going to have 1 over what? 2j into what? Minus 1 over what? S minus 1 minus what? 2j. Okay, so the same thing over here. Okay, so the same thing over here. So plus 1 over what? S minus 1 plus what? 2j. Okay, so this is what you're going to get at this particular stage. Okay, so now if I should expand, then I'm going to actually have here, I can bring this one up, I can bring this one up. Okay, and then the denominator will be what? Their products. Okay, will be their products. Okay, so now basically what I can have is, I can have this one and this one, it will be squared. This one and this one, it will be what? Squared. Okay, so I can actually say that I can have 1 over what? 2j into what? 1 over 2j into s minus 1 plus 2j, okay, plus, okay, s minus 1 minus what? 2j. Okay, I can have this one. Then I can have s, okay, minus 1, okay, minus 2j, okay, and then so this one is one part, and then I can have what? S minus 1, okay, plus what? 2j. So this one is also another part. Okay, so that is what I can have. So if I do that and I do my multiplication, okay, then I'm actually going to have here, what is going to happen is that this one and this one, okay, they will add, this one and this one, they will this one and this one, they will cancel out. Okay, they will cancel out. And then one thing that I should also know from here is that I'm going to actually have, here is minus. Okay, there is minus here. All right, there is minus here, which we must also what? Remember that there is a what? A minus here. Okay, that there is a minus here. Okay, because of that minus, so this guy will become what? Minus, and then this guy is what? Positive, so they will cancel. Here is positive, here is minus, they will what? Cancel. Okay, and then what I'll have here is that I'll have here to be what? This place will be what? This place will become okay, so here, this time this one will become negative. Here is positive, so they will cancel. This time, this guy will become positive. Here is negative, so they will cancel. This guy will become more negative. Here is negative. So you get what? Negative 4j. Okay, so you get 1 over what? 2j into what? Negative what? 4j over what? Here, this guy and this guy, they will be squared. So s minus what? 1 what? Squared. And then, because what will happen is that this time this will be positive. This time this will be negative. They will cancel. Then this time this one. Okay, you're going to have what? Plus 4. Okay, you're going to have plus 4 because j into j is minus 1. 2 into 2 is what? Is minus 2 into 2 is what? Is minus 4. Then the minus 1 will make the minus 4 what? Positive 4. So you have what? Plus 4. Okay, so this is what you get. So now if you should cancel out, you get minus 2 over what? S minus what? 1 what? Squared plus what? 4. Okay, so this becomes your Laplace transform. Okay, so now your Laplace transform of x of what? Of t of this particular function in question is minus 2 over what? S minus what? 1 what? Squared plus what? Plus 4. Okay, and then what will be your region of what? Convergence, your ROC. Okay, so your ROC. So now here, your ROC, you can take your ROC with respect to this and this, with respect to this and this. But already we are told that the signal is what? At the negative side of the what? X-axis. So that means that RU of S will be less than what? 0. So now here, t minus what? Here is 1. It's 1. So you're going to have 1 minus 1 and then 5. Okay, so please let me just write it for you to see. Okay, so basically you're going to have 5 and then here is actually going to be what? Minus 1. Okay, why am I saying that it's going to be minus 1? It's going to be minus 1. Very simple. Okay, let me just show you. Okay, because basically we're going to have minus 5, okay, minus 1, okay, because our function is what? Our function is et, okay, into what? Into e minus what? Minus 5 what? T. Okay, so minus 5 minus 1 into what? T. Okay, so that's what you're going to actually what? Have. So we're going to have e exponent what? We're going to have e exponent this one. And then with respect to the math here, it should be less than what? Infinity. And with respect to mathematics, depending, and we know that our t is less than what? 0. That means that our graph is lying in the region what? Which is less than what? 0, in the negative what? Region. So for it to be less than what? For it to be this function to be less than what? This infinity. Okay, here is integral. Okay, for it to be less than infinity, and here is absolute. For it to be less than infinity, then what happens is that 5 minus what? 1 must be what? Because here is at the negative side of the x-axis, so it's at the what? Negative. So it's at the negative region. Okay, so it should be what? Less than 0. Okay, so now here 5 will be what? Less than what? 1. Okay, so that's why I'm saying that here is minus 1. Okay, so now you know that here becomes what? Minus 1. Okay, so minus 1 is less than what? 0. So now real of s, which is what? 5, is less than what? 1. Okay, so here what I can say is that real of what? S is less than what? 1. Okay, so basically that's how you can complete this particular aspect. Okay, but please, I haven't done the I think, yeah, you just have to end it here. Okay, for this particular question. Now let's go on to the next question that we have. Okay, so what is our next question? So this is our next question. Our next question is such that x of t, x of which is c, x of what? T, okay, is equals to e into what? 2t, okay, into u of minus what? T, okay, plus what? E into what? 3t into u of what? Minus what? T. So simply the Laplace transform of this one is going to be 1 over what? S, okay, minus what? 2, okay, 1 over S minus 2, okay, But what happens is that this is at the negative what side. So our s here is going here. This is going to be negative, okay? And then we're going to have this one also minus, because here is minus. Okay, it will affect here to what 1 minus 1 over what s minus what 3. Okay, so that's our Laplace transform. Okay, so our ROC is going to be such that R of S, RE of S, real of S, okay, our real of S is going to be here is going to be less than, okay, it's going to be less than 2, okay, it's going to be less than 2, because it's going to be at the what, at the negative side, okay, of the x-axis, okay, and here also our RE of what, S is going to be what, less than, okay, it's going to be less than what, 3, okay. So if you should plot your s-plane, okay, here is what, s-plane. If you should plot your x-plane, here is what, j omega. Here is imaginary of what, s. Here is what, sigma. Here is what, real of what, s. So where is 2 and where is 3? Okay, so let's just do this. Okay, sorry, my imaginary, I cannot put anything here because I have 2 and I have 3. They are not negatives, okay? So please, let me draw it again. Okay, sorry. So here I have this place, imaginary of what? S. And I have here to be what? J omega. And I have what? Real of what? S. And I have here to be what? Sigma. Okay, here is 0. So let's say this place, okay? This place is what? RE of what? S is equals to 2. And then this place is what? RE of what? S is equals to what? 3. Is equals to 3. Okay, so these are the things I have. Okay, so now both of them, you see that both of them is less than, or RE is less than 2 and is less than what, 3. Okay, so who are less than what, 2? So the RE of S that are less than 2 are going this way, and the RE of S that are what, less than 3 are also going this way. Okay, so where is our intersection? So our intersection is what, RE of what, 2, RES of 2. So final ROC, okay, is going to be what, RE of what, of S less than what, less than 2. Okay, RE of S less than 2. So that will be the end of this particular question also. So now we can just go to the next question. Okay, so let's take a look at the next question. So in the next question, we have x of what, t, which is d. Okay, x of t to be what, equals to t, okay, into what, e minus 2 mod what, t. Okay, so okay, mod t. Whenever you see mod t, it means that you should take the negative and the positive aspect of it. So here, if you want to take the Laplace transform of x of what, t, okay, then you're going to have to take it like minus what, infinity, okay, minus infinity to what, infinity. X of what, x of t into e minus what, st d what, dt. Okay, and this is equals to, and this is actually equals to this one, and this is actually equals to minus infinity to what, infinity. What is xt of t? Okay, xt of t is what, t into what, e minus what, 2 mod what, t, okay, into e minus what, s what, t, d what, dt. Okay, so basically that is what you get over there. Okay, so now if you have it this way, then we can just go on ahead. But before we go on, please let's plot these two graphs, or these graphs. Whenever you have mod t, it means that you must take both the negative aspect and then the positive aspect. Okay, so basically we're going to take one signal, okay, one signal that is going to be here. So here is t, so it's going to be something of this sort. If let's say here is our t, okay, if here is our t, okay, then we're going to have something of this sort. Sorry, it will not touch the x-axis, it will just be close to it. okay, something of this sort. Okay, here is what? Infinity. Here is minus infinity. Here is 0. Here is x of what? T. Okay, and here is where you're going to have the negative aspect of it. So here is where you're going to have e minus 2 what? T. And here is where you're actually going to have e exponent 2 what? T. Okay, so this is how the graph will actually look like. Okay, so this is going to be very helpful as we move along. Okay, so now from here, what we can just do is that we can just say that here is going to be equals to minus infinity to what? 0. Minus infinity to what? 0. Okay, and then we have t. Okay, here you see that the function is what? Et. Okay, e2t. Okay, into what? Into here e. Okay, minus what? St. Okay, minus st. All right, plus here 0 to infinity. 0 to what? Infinity. What's the function here? E minus is t minus 2t into minus what? St. Okay, here you can bring the t. Okay, here is also the t. Okay, all right. So basically, that's what you can write here. But if in case you don't know it this way, there's another way you can also take it. Okay, here this minus 2. You have to take the negative aspect of this t and the positive aspect of this t. So if you are taking the negative aspect of this t, then it will what? Minus t times minus 2. That will give us positive what? 2t. So that is this what? Positive 2t, which is the negative aspect. And if you want the negative, that is the negative aspect. The negative aspect, you multiply the negative of this t. That's negative t times negative 2t. That will give you positive what? 2t. That is this positive what? 2t, which is this, which will correspond to the negative aspect. Now, if you want the positive aspect, you multiply positive t times negative 2. That will give you what? Negative 2t, which is this positive what? Aspect. All right. So this is how you can deal with this particular function or this particular signal. All right. If you're doing signals as system, so I must be saying signal. Okay. So now, if you have it this way, then you are almost half gone. So from here, what you can just do is that from here I can just say that minus infinity to what? 0. Okay. T into what? E. Okay. Minus what? Minus out. I can have s. Minus out. I can have s. And then plus what? 2. Okay. Plus 2. All right. No. Please. Let me cancel it. Okay. So please, I'm going to have here minus what? Infinity. I'm going to have here minus infinity. I'm going to have here 0. Okay. T. E. Okay. Minus out. S. Okay. S minus what? 2. Because negative times negative will give me what? Positive. Okay. Then here into what? T. The what? The T. Plus what? Here 0. Infinity. Okay. I'm going to have what? T. E. Minus out. S. Okay. So here I'm going to have what? Plus what? 2. So that negative times positive will give me what? Negative. Okay. Here T. The what? The T. Okay. So basically that is how you can actually deal with this one. But now here you have to use what? Integration by part, or the UV rule, because this is one function T and this is another function. Okay. This one function. Okay. This is another function. So we have two functions. So we have to use what? Integration by part. So say here use UV what? Rule, or what? Integration by what? By parts. Okay. So that's what we have to do here. So now if I should use UV rule for this one, then basically what I can say is that it's going to be equals to here I'll take this one, differentiate this guy. Okay. Okay, so now I'll take what? T. Okay, so in that case, my T here, what is going to happen is that it's going to be negative. Okay, it's going to be negative. All right, so here I'll have negative T. Okay, into negative T over what? S minus what? 2 into what? E minus s minus what? 2. Okay, okay, yeah. And then I'm going to have minus, and then I'm going to integrate minus. Then I'll differentiate this guy, I'll get 1. Then integrate this guy what? 2 times. If I integrate this guy 2 times, that minus is here. Please, you visit our other lectures for integration by part. Okay, so here e minus what? Especially the Fourier transforms, the other part. Okay, minus s minus what? 2. Okay, here like this. Okay, into s plus what? S plus what? Sorry. S minus what? 2 or what? Square. Okay, that is what I'll get here. Okay, that is what I'll get here. All right. So basically, that is what I'll get here. Okay, so that's what I'll get here. So then I can close here, and here is what? Minus infinity, and here is what? 0. Okay, then let me move forward. Okay, so if I move forward, then I'm going to get here also similar thing, integration by what? Part. Okay, so if I do integration by part of this particular aspect also, I'm going to have here is what? Negative. Okay, here is negative. So this negative, if I integrate, I'll get 1 over what? S plus 2. But because of this minus, I'll get what? Minus t over what? S plus what? 2 into what? E minus what? S plus what? 2 into what? T. Okay, into t. Okay, then I'll have minus. Okay, I'll have minus, and I'll integrate this guy. I'll just differentiate this guy. I'll get 1, and then I integrate this guy 2 times. So I'll get e exponent minus s plus what? 2 into what? T. And then here I'll get s plus 2 what? Squared. And then here I can close it. Okay, and here I can close it. Okay, please be reminded of my limits. Okay, be reminded of my limits. That is what? 0 to what? Infinity. So it's what? 0, and here is what? Infinity. Okay, please. So that is how you can actually do this one. Okay. So now if I should introduce my limits, what am I going to get? Okay, so if I put 0 here, this whole function will become 0. If I put 0 here, I'll get what? 1 over what? S minus 2 what? Squared. But because of this minus, it will be what? It will be minus. Okay. Okay, now if I put negative infinity here, if I put, please, what happens is that here is what? T. Here is T. Okay, T. Okay, so if I put negative infinity here, okay, if I put negative infinity here, what am I going to get? Okay, so negative infinity actually is supposed to give me, whenever I have any function as what? Negative infinity, I'm supposed to get 0. Okay, so if I put negative infinity here, you see that s minus 2 actually, you see the limit is from minus infinity towards 0. It corresponds to what? The negative aspect of the graph. Minus infinity towards 0. It corresponds to what? The negative aspect of the graph, which is this part, the negative aspect. So now if I put negative infinity here, I'll have here, this is one negative. S minus 2 is negative. Why is it negative? Because it is found at the what? Negative region of the graph. The negative x, the negative z, the negative x aspect. Okay, because you see that it's minus infinity towards 0. It's minus infinity towards 0. So that means that here is negative, s minus 2 is negative, and then here also I'll have what? Negative infinity. That means that I'll have 3 negatives. 1, 2, what? 3. 3 negatives is equal to what? 1 negative. Okay, so that means I'll have negative what? Infinity. Negative infinity is what? 0. Okay, and the same thing will come here. So this place will also be what? 0. So if I put negative infinity here, I'll get 0. If I put negative infinity here also, I'll get what? 0. So the only thing that remains will be what? This 0. And this 0, when 0 comes here, is what? 0. And when 0 comes here, that's the only place you have a number. It is what? E exponent what? 0. Which is what? 1 over s minus what? 2 or what? Squared. So I'm going to have minus what? 1 over what? S minus what? S minus 2 or what? Squared. Now, if I come here, here, this place, where is this graph lying? It's between what? 0 is between what? 0 and infinity. And 0 and infinity is at the what? Positive side of the what? X-axis. Okay, so that means that this negative here is what? Positive, because x plus 2 is what? At the positive side of the graph. And here's what? Infinity. So I'll just get what? Negative what? Infinity. Okay, so now negative infinity is what? 0. So that means that if I put negative infinity here, here is negative, here is what? Positive, because at the positive side of the what? Of the graph. Here is what? Infinity. So negative and then infinity. So negative infinity. Negative infinity is what? 0. So that means that the whole of this part becomes 0. Now, if I put infinity here also, it will be the same thing. Negative, positive, infinity. So negative infinity. Negative infinity is what? E exponent negative infinity is what? 0. So this whole part also becomes what? 0. Now let me put in my 0. If I put 0 here, I'll get what? 0. If this t is 0, the whole thing becomes 0. Now if this 0, if I put it here, I'll get what? I'll get e exponent what? 0. Okay, which is what? 1. So minus what? 1. So I'll get minus what? 1 over what? S plus what? 2 what? Squared. Okay, so basically that is what I'm actually going to what? Get. Okay, so now but mind you that this negative is this one, but this 0 here is a limit. It's a limit. A limit must always what? Subtract. So that means that I'll have another what? Negative. Let me do it this way. Okay, which is equals to minus 1 over what? S minus 2. Okay, or what? Squared plus what? 1 over what? S minus 2 or what? Squared. Sorry, S plus 2 all squared. So that this becomes the Laplace transform. So x of what? S. Okay, this becomes the Laplace transform. Okay, so now let us briefly find our ROC. Okay, so now my ROC. So now my ROC for this part. Okay, my ROC for this part. So let me just, to find the ROC, let me just come here. So you see that this place is what? At the negative side of the x-axis. And then, so real of s, okay, will be what? Less than what? Will be less than this 2 will be less than what? 2. Okay, so here I will say that RE, okay, of s will be what? Less than what? 2, because it's at the what? Negative side of the what? X-axis. Okay, and here what I'll have is that real of what? S. Okay, real of s will be greater than what? Will be greater than what? Negative what? 2. Okay, so here and what? Real of what? S. Real of s, okay, is greater than negative what? 2. So that would be my what? My this one, my ROC. So now I can say that if you have t e minus 2 mod t, okay, if you have this particular what? Function, okay, then your Laplace transform is supposed to be what? Minus 1 over what? S minus what? 2 all squared, okay, plus 1 over what? S plus what? 2 all what? Squared. And then your ROC will be what? Real of S, okay, less than what? 2. And then you have real of what? S, okay, greater than, sorry, please, here is greater than, sorry, here is greater than, sorry, greater than minus what? 2, greater than minus what? 2. So this will be the solution for this particular one. Okay, thank you so much. See you in the next class.